Hey class, Mr. Bean here. This is for geoscience here and possibly physics as well. I'm going to go over in geoscience, this is going to be project uh, 2.1, learning how to graph. Okay, so when we click on this link here, it brings us to this page here and it says here begin, but also says to open up a graphing program. So we'll go and click on this here. And what I'm going to do is I'm going to split screen this. So I'm going to put this over here because we'll need to use this as we go about our business. All right. So anyways, that's a quick graph tool. So let me go ahead and go back to our program here. Let's see. Uh, see where are we at here? Let's see. Okay, hold on here. Okay, here we go. Back to homework. And let's click on that. And data generator. Let's see, where is that at? Here it is. Okay, curve fit. Okay, we'll go ahead and click on begin here. And it says here, so yours might be different, but this is how they all appear here. So it says here the speed of an accelerating object at various times after starting. Okay, so speed of an accelerating object at various times. Okay, so in here, what is changing? Okay, it's the times are changing, and the speed uh, is going to dictate the time. Okay, so speed. So over here, we have here that the time is changing. So time here is in the x-axis here, and speed here is in the y-axis. So in other words, x and y, this would be the independent variable, and this is the dependent variable. So in this setup here, we're finding out how does time affect speed, or how is speed affected by the time? Okay. All right. So what we'll do is this is X here. So I'm going to go over here, make sure you label this here. I'm going to cross that out, and I'm going to go ahead and write in here time. Okay. And we'll say in seconds. Okay. And here, the dependent variable will be, we'll say here will be speed. Okay, here's speed, and it'll be meters per second. Okay, so whatever x, now yours might be temperature, volume, or what have you, but this will be the x-axis or the x coordinates. This will be the y coordinates. All right, so let's just go and start plugging it in here. So 0, 28, hold on. So 0, tab. Here's so 0, 0. I'm going to hit press tab, 28 tab, 5.64 tab 7, 2.87, 19, 4.65, 31. Okay, and here's 5.83, 19, 4.65. Okay, 31, 5.83. Okay, here's 19, 4.65, 25, 5.51, 31, 6.05. Here's 10, and 3.43, 9, and 3.21. All right, so I have my graph here. And let's double check. Let's make sure we're right. 0, 0, 28, 5.64. Here's 7. Okay. Here's 7, 2.87, 19, 4.65. Here's 31. Okay. And let's make sure we double check here. Distance over time. And let's see here what we got. Uh, okay, distance over time. All right, so let's take a look here and let's take a look at our curve fit. Let's see what seems to work. So if I do proportional, okay, so I want the line that connects most of the dots, okay? Here's linear, okay, that's a possibility here. Possibility. Notice here, here's the equation y equals mx plus b. Okay, let's try, okay, this is squared. Okay, here's cube. Here's square root. Oh, wait a minute. Square root here seems to kind of fit here, but we'll keep this as an option. No relation. Here's inverse. Here's inverse square. Okay, so these aren't working here. So let's take a look at square root here. So here we have square root. Okay, so this seems to be fitting here. So what I would do then is I would screenshot the table and the square root here to show that this is a perfect fit. All right. If there are any questions, please come see me.